Hello and welcome to Fundamentals of Cybersecurity, CSCI150N Chapter 16, Email and Instant Messaging. I'm your instructor, Peter Keurig. In this chapter, you will learn how to describe security issues associated with email, implement email security practices, and detail the security issues of instant messaging protocols. The outline for this chapter is how emails work, security of email, mail encryption, and instant messaging. Internet email depends on three primary protocols: SMTP, POP3, and IMAP. Simple Mail Transfer Protocol, SMTP, is the method by which mail is sent to the server as well as from server to server. SMTP by default uses TCP port 25. And then POP3, which stands for Post Office Protocol version 3, which by default uses TCP port 110. POP is a method by which a client computer may connect to a server and download new messages. POP3 has been partly replaced by IMAP, or Internet Message Access Protocol, which uses port 143 by default. IMAP is similar to POP in that it allows the client to retrieve messages from the server, but IMAP typically works in greater synchronization. For example, emails are left on the server until the client deletes them in the client end, and at the which time the IMAP instructs the server to delete them. As email servers become more standardized, the method of transmission becomes easier to attack, as they were not strange proprietary protocols. Also, the world became more connected. There were many more available targets for malware and commercial emails. In this chart, you see what normal ports are used by those three protocols. As I said, port 25, port 110, and 143. But if you use the secured version of those protocols using TLS to encrypt the traffic, SMTP will use 465, POP3 will use 995, and IMAP will use 993. The way that email works, email appears to be a client-to-client communication between sender and receiver, but in reality, there are lots of steps involved, as shown in the diagram. First, a user composes and sends an email from the client's machine. The email is sent to the client's email server. In an internet service provider environment, this could be the ISP provided. In the case of an enterprise, it could be their Exchange server, something of that sort. The receiving email server scans the email for viruses, malware, and other threats, and uses the DNS to obtain the recipient email server address via a MX record. The mail server prepares the email for transit across the internet to the recipient mail server. The email is routed across the internet. The receiving email server scans the email for viruses, malware, and other threats, and then the email is passed to the recipient's inbox where it can be read. This list of steps leaves out a lot of details, but it provides the main step in the email transfer. The sender's machine is referred to often as the mail user agent, or MUA, and the mail server is a mail transfer agent, MTA, and the recipient's mail server is referred to as the mail delivery agent. These terms are used when discussing mail transfers to provide accuracy in the conversation. The email structure, it's basically a telnet session into a port 25 of the SMTP server, and it's all sent as plain ASCII text, with attachment included using base 64 encoding to encode the binary to ASCII text and decode it back. The email headers provide information on how to handle the email, on who it's being sent from and who it's going to, who it's passing through along the way. When a message has an attachment, the protocol used to deliver the message is Multi-Purpose Internet Mail Extensions, or MIME. This protocol allows the exchange of different types of data across text-based email systems. When MIME is used, it is marked in the header of the email, along with the supporting elements to facilitate the decoding. Book shows an example of this. So we stated that email is sent as ASCII text, so it's pure plain text. But that doesn't mean that it's limited to just plain text. What it means is that that's how it's transmitted, but But in reality, most of us know from our Gmail or Yahoo or whatever that you can have HTML-based emails. So really what it is just passing the HTML as plain text, and the receiving end mail client is interpreting it as HTML. And because of that, you can get things such as mobile code, such as Java, ActiveX, JavaScript, VBScript, and so forth, put into the email message, so that if you open up that email message in a web-enabled email client, such as Outlook, it will execute the malicious code. You could have mobile code injected into your email messages and used as a vector for attack or infection. You could have viruses and worms added into the code, or attached to it as an attachment, and maybe embedded inside the attachment like a PDF file. But the HTML capabilities of email today, which makes it look nice, you can send out some nice emails, some good advertisements and things like that. But the HTML makes it vulnerable. And what you'll find is many organizations that want to reduce the risk of emails providing security risk on their network will actually disable the capability for HTML to be viewed through their mail client. Rather, it comes through as looking like a bunch of HTML tags or markups, and the links themselves might also be disabled. Hoax emails are usually urban legends. They talk about doing certain things that have happened or whatever, like be on the lookout for this killer or be on the lookout for this missing child, and many of them turn out not to be true. Then there are superstitions and chain letters. If you don't forward this within 5 days, your kitty cat might die, and if you pass this email on to 100 of your closest friends within the next 5 minutes, you'll get $1 million or something of that sort. And then there's fake news stories that circulate. Hey, did you hear about this? And there's a lot of newsletters out there from incredible news sources that can be passed around by email and subscribed to. You see this in the investment community. You get all these different investment newsletters and things like maybe penny stock trading community or whatever. So people subscribe to it thinking they're getting good information for trading. In reality, they're all hoaxes, and they're just trying to convince people to buy shares in a bogus company or an underperforming company to make a profit. Unsolicited commercial email, spam. This is done through open relays and mail relays that are not properly secured, not properly authenticating back using the MX record to validate that the person connecting to the SMTP server is a valid user. And lots of botnets will send out spam email, and they'll use as many systems as possible to be the source of their emails. There's open relays and mail relays. An open relay is an unsecured SMTP server. Basically no proper password authentication. So if you telnet into port 25 on that SMTP server, you can spoof an email coming from it. Mail relays, similar to dropping a letter off at post office instead of letting the postal carrier pick you up at your home. And the internet, that consists of sending an email from a separate IP address, making it more difficult for mail to be tracked back to you. Often they'll use black hole lists, where if the source of the email is resolves back through the MX record to a domain that is not acceptable or has been known for a lot of spam, it'll block taking the or accepting the email message from wherever its origin is. Then there's Sender ID Framework. Microsoft offers another server-based solution to spam called Sender ID Framework. It attempts to authenticate messages by checking the sender's domain name against a list of IP addresses authorized to send an email by the domain name listed. This is maintained in a text file record published by the DNS called a Sender Policy Framework. So when a mail server receives a email or message, it will check the sender's domain name in the DNS. If the outbound server's IP matches, the message gets a pass rating by the Sender ID framework. This is similar to the idea that routers have dropped any outbound port 25 traffic that doesn't come from the known email server. In addition, organizations can help out with the spam situation by setting it up so that their SMTP relay does not forward email out through the firewall to another SMTP relay or SMTP server port 25 without there being some kind of authentication or being on a whitelist. Domain Keys Identification Mail, DKIM, is an email validation system employed to detect email spoofing. DKIM operates by providing a mechanism to allow receiving MTAs to check the incoming mail is authorized and that the email, including attachments, has not been modified during transport. It does this through a digital signature included with the message that can be validated by the recipient using the signer's public key published in the DNS. DKIM is the result of merging two previous methods, domain keys and identification internet mail. DKIM is the basis for a series of IETF standards, track specifications, and is used by AOL, Gmail, and Yahoo Mail. Any mail from these organizations should carry a DKIM signature. So we said that earlier that email is sent unencrypted as plain ASCII text from mail server to mail server across the internet. So basically anything that's in the message can be read. So think about that when you get these password resets. And this is why some of these password reset emails, you only have like a 15-minute period before that temporary password or link is no longer effective. It's so that if somebody intercepts that message a half an hour later or whatever, they're not going to log in successfully. But if you email unencrypted across the internet an actual password or financial information or your social security number or whatever, it's out there for people to see and to intercept. Because of that, there are ways that we can protect our email by using encryption. A good example of that is SMIME. I talked about this once a long time ago to the class about Outlook Web Access. And it's SMIME is the secure multi-purpose internet mail extensions that can be added in as an add-in to Outlook Web Access. Google Mail also offers it. Basically, you could take a PKI certificate, and you can give out your public key and use your private key to encrypt emails and to receive encrypted emails. SMIME was developed by RSA Data. It supports both 40-bit and triple DES, 128-bit for symmetric encryption. The SMIME process for encrypting email provides integrity and privacy, and if the message is signed, it's authentication. Several popular email programs support SMIME, as I said, Microsoft Outlook, even Windows Mail does. They both manage SMIME keys and functions through the email security screen. Gmail, as I said, offers it. And while SMIME is good and versatile protocol for securing emails, its implementation can be problematic, and SMIME allows the user to select low-strength encryption, which means the user can send a message that is thought to be secure but is more easily decoded than a message that uses, let's say, triple DES encryption. And in this chapter, although instant messaging is not email, it is put in here because it's got a lot of similar features. It's widespread, accepted in use today on the internet, and it's growing in popularity with programs like Snapchat or Facebook Messenger, things of that sort. But its real roots were founded in the AOL Instant Messenger and some other tools that were available around that time. For example, I worked back in the early 90s at a internet service provider, and I wrote a chat room using Perl scripting and HTML, and it was based off of a web server that allowed multiple chat rooms. But the premise of it's the same. There's a server that serves out to the clients that are communicating back with it. It's usually sent as HTML. Some of them do it secure now using TLS or SSL to encrypt the traffic, while others are still using it wide open and unencrypted. there's a misconception that what you say in an instant message is private. It's really not. It's stored more often than not on the server as part of a history. So if there was to be a subpoena or whatever, the organization hosting that particular instant messenger might be able to go back and retrieve those messages. I'm your instructor, Peter Keurig for Nashville Community College. Thank you for watching.